All right, so in this example, we are going to perform loan payment calculations using the loan payment function in Microsoft Excel. I have Excel opened on my computer. I have a link in the description on how you can sign up for the free online version of Microsoft Excel if you do not have it. So to do this calculation, I will increase my font size to 22 for the fields here so we can see things a little bit clearly. All right, let's say we want to do payment for $250,000 loan. Term is 30 years. And the interest rate is 7%. So within Excel, there are two ways I can invoke that function. So first I'll enter equals to sign and a negative sign, because the function is built to return a negative value. To reverse it, I put a negative sign. So once I type equals to sign in a cell, if you look in your formula bar, you will see functions here. Because I've used PMT recently, PMT shows up there. This is the function in Microsoft Excel that will calculate loan payment based on constant interest rate and constant payment. In your case, you may not see PMT. You may have to scroll down the list. And if you still do not see it, you click on more functions until you see PMT. So I'll select PMT. Once you select PMT, it will open this dialog box. And now for my rate, because we are doing the calculation for 7% interest rate, so you can enter 7%, or you can enter the actual number. You can see to the right, it also tells you that the actual number is 0.07, but you cannot enter 7 in this function. And now another thing is, it will tell us, if you look below, it says that this function calculates the payment for a loan based on constant payments and a constant interest rate. So for the field that we selected, rate, it says it is the interest rate per period for the loan. For example, use percent divided by 4 for quarterly payment at 6% APR. Because we are looking at the monthly payments for our loan, so we are going to divide that by 12. Next, number of payments. Again, it defines that as the total number of payments for the loan. So because we are looking at 30 years and monthly payments, so we are going to have 30 times 12. So you can put 30 times 12, and it will give you the number as 360. You can also enter 360 here. So the next value, PV, is the present value, the total amount that a series of future payments is worth now. So essentially, it is the loan amount. So for our loan amount, that's $250,000. $50,000. Now, there are two other fields which we will not need to bother about, but just for purposes of explanation. So FV, it says, is the future value or a cash balance you want to attain after the last payment is made. 0 if omitted. All right. In some cases, you may be interested in calculating your payments, monthly payments, up to a certain outstanding balance. Let's say by the time you finish all your payments, you have an outstanding balance. Let's say we want to do this calculation and you want to have $50,000 at the end of the 30 years. Then this is where you enter that value. And the default value is 0. You can enter 0 if you want the final payment to be 0, or you can also omit it. It will assume it to be 0. Because we want the final value to be 0, we can enter 0 here, or we can simply omit it. In this case, we are going to omit it. All right, so the next field also talks about type. It says it is a logical value payment. It's a logical value. Payment at the beginning of the period equals to 1. Payment at the end of the period equals to 0 or omitted. Now we know in our calculation that payments are done at the end of the period. So your lender usually will calculate the interest at the end of the month, and you send in your payments for the end of the month, at the end of the month, at the end of the period. So that is 0. So the default value is 0. If the payment is at the end of the month, we can put in 0, or we can omit it. It will assume it is 0. So in our example, payment is going to be at the end of the month. So we are going to simply omit it. So the 3 variables are what we have to deal with. So once we have the 3 values entered, we can click OK, and it will tell us that the loan payment, monthly loan payments, will be $1,663.26. As you can see, it is very, very simple. It opens the dialog box and you enter your 3 variables. You click OK and you have your payment. So this is one method that one way we can invoke the payment function in Excel. There's another way I can invoke that function. I can simply type equals to and then type the negative sign. Since I know that function, I can type PMT and then open bracket. It will tell me, it will then start asking me, it will open the dialog box where it asks me for the variables, the arguments. So for the first one is the rate. So if I'm doing that same calculation, the rate is 7%. I can enter 7%. And 7% is the yearly rate, because we are looking at performing monthly calculation. We are going to divide that by 12 to get the monthly rate. The next argument is number of payments. 30 years times 12. So once you enter an argument, you put comma, and then the last variable it asks for is the loan amount, which is $250,000. So I enter $250,000 and close parentheses and hit enter, and it gives me that value, $1,663.26. So you have the 2 ways that you can invoke the function in Microsoft Excel. And we can see the function is already formatted as currency and everything to 2 places of decimal. So next, we are going to explore the inbuilt power of Excel to do a number of calculations at the same time. So let's begin with 5%. I'm going to do a number of calculations at the same time. 4.5%. We'll do 6%, 6.5%, 7%. Now let us format the fields a little bit. So I'll quickly format my fields here. And then I'll do this as format cells. I'll use that as percentage, 2 places of decimal. And then let's begin with 100,000. I'll format this as currency. Format cells. I'll use currency, 2 places of decimal. So when I put 100,000, let's go by 50,000 increments, 150,000, 200,000, 250,000, 300,000, 350,000, 400,000, 450,000, 'Sorry, I did not format this. Okay, so I'll format that into format cells. I want that to be currency. Then this will be 500,000. All right, so this will be 22. So we want to utilize the power of Excel to do a number of calculations at the same time. All right. I'll enter that again. So let me just type the term here. It's for 30 years. All right. So we enter our equal sign negative, and then we type PMT. It opens our argument. Rate will be, we enter that divided by 12, and number of payments will be 30 years times 12. 30 years times 12 months. And then the payment value, in this case, is 100,000. So it tells us the monthly payment will be $536.82. Now I do not want to keep typing this formula for all these fields. I want to copy this formula and paste. So it will perform all those calculations for me at the same time. So to do that, I have to format the formula. So for each of these fields, it will know, for example, here, it will know to use 6.5% and 200,000 loan amount. For this field, it will know to use 7% as the interest rate and 350,000 as the loan amount. So now here, we see that our interest rate is on row number 10. Interest rate is on row number 10. So we want it to track row number 10. So our interest rate is on row number 10. So I'll enter the $ for beside the number 10. So it will track row number 10. Now for our loan amount, we want it to track this column F. For our loan amount, we want it to track column F. So I'll enter the $ beside F. So once I finish, I've done that. So I have my formula formatted. Then I can simply copy and paste. All right, so just telling us that we need to widen our fields a little bit. So once we widen our fields a little bit, our numbers will show. All right, so there you have it. The calculation is done. So for 7% interest rate, $150,000 loan at 30-year term, we'll have $997.95 as the payment. If the interest rate increased to 7.5% and the loan amount is $500,000 at the same term of 30 years, the payment will come to $3,496.07. So this is how we can employ or harness the capability of Excel to do quite any number of calculations at the same time.